Right, so matter does have mass and volume, so it takes up space basically. So we know that we have been messing with matter, right? We've been weighing it, we've been measuring it to take volume. Everything is matter though, except for energy. I think that is a cool fact, but it's also something we're really going to start talking about next unit when we talk about energy. So an example of energy would be what here? Light waves, right? Light waves are a form of energy. And you saw something like called wavelength on number 15 last night, okay? So I will have a look at problem set 3B whenever I get a chance to go through the class. So make sure that is available for me there. So this right here I have printed for you, yes? Okay, so all I really want to talk about is the difference between pure substances and mixture of substances. Pure substances are only two different things, okay? They're either elements, okay? Where would you find the elements? Thank you. PTOE, periodic table of elements, right? PTOE is how I will abbreviate that. So an element is just its own, it's just a bunch of atoms of its own type, okay? A compound is also considered a pure substance because it's a direct or a distinct ratio, fixed ratio of these elements that we've talked about, the periodic table of elements, right? So if I said water, we don't get to make up what it is. It's H2O. So for every one oxygen, how many hydrogens have to be there? 2. For hydrogen peroxide, for every 2 hydrogens, there must be 2 oxygens. So it's a fixed ratio that we can't pull that hydrogen from the oxygen. Physically, we cannot pull it apart. We can chemically react it, but that's going to be chemical means of breaking down, not physical means of breaking down. So you must know that elements and compounds are considered pure substances because they have this defined composition of what they're made of or a ratio in which they exist. Cool? Okay. The other ones are just going to be homogeneous or heterogeneous mixtures, and they are, hetero means different, homo means same. The words kind of, the prefixes are exactly what they mean. And so these are like chemicals and then chemical compounds, compositions. This is more of a physical combination, right? So I can take and make a mixture. Right now, what is in my beaker? As you can probably assume. Just water, right? And so I can make a physical combination. Let's do this one. I'm not going to get this all over me or anybody else. I can make a physical composition, mixture by just dropping another source of a pure substance in it, right? So water is a pure substance. Why? Water is a pure substance. Why? Has a fixed ratio, right? This food coloring is some humongous organic structure, okay? It has a fixed ratio too. But I can put 2 pure substances together to make a mixture. Does this look the same throughout or different throughout? The same. So what kind of mixture? Homogeneous, right? So that's really easy to see that. You can take 2 different things and put them together. It's just the whole vocabulary part behind it. I will say, the properties of this mixture doesn't exactly change the properties of the 2 substances that went in it. I can actually separate that again. It's hard, but I can separate that through distillation. You can distill different things at different boiling points out from each other. Okay, so this right here is a flow map of what I was looking kind of for on number 3 of reading guide 2. Yeah. So some people drew something very similar to this. When I said map it, kind of, you should have had somewhat of a flow map, I guess. But what we need to be aware of is that we can take mixtures and we can separate them back into their 2 pure substances. And one of the ways is chromatography. I don't believe I put this on your paper. Did I? This was on reading guide 2 though. 1. So chromatography is something we're going to do tomorrow, and it separates. Not tomorrow, I'm sorry. It's Tuesday. So it separates mixtures, separates pure substances based on solubility. Okay? It separates things based on solubility. So we're going to learn how some things are soluble in water and some things are not when we get to that part. Filtration, I'll demonstrate momentarily, but what 2 phases of matter does filtration separate? There's only 3 states of matter. You got like a 33.3% chance of getting this right. Liquids and solids, right? So filtration works to separate liquids versus solids because the filter catches the solid. And then distillation, here has that definition. What does it work by? Separation based on what? It's on your reading guide. So I'm doing the vocabulary part. Separates based on, say again? Boiling point, right. Separates BP, so I don't always write complete sentences. You can figure it out. Separates based on boiling point. So what's the boiling point of water in Celsius? 100. Something else might boil, like ethanol. Ethanol boils lower than that, like 91 degrees Celsius. So ethanol boils off first, leaves the water behind. Boom, we've separated ethanol from water. So it's not bad to know the separation techniques, because they're really not that hard. It's just these new words like distillation and chromatography you may not have been really exposed to before. So that's how we can take a mixture and separate it back to its pure substances. If I wanted to break down a chemical compound like water, I have to use a different means. So one of the most common examples is electrolysis. So let's break this word down, because it's going to break down chemicals, right? You guys. Okay, so what do you think it uses to break down chemicals, based on the word? Electricity, right? So it's going to shoot electricity through something to break the chemicals apart. This back part of the word, lysis, what does that mean? Lysis, go for it. To cut or to break, right? So this literally means electricity is breaking something apart, okay, to break. This is like catalysis. Catalysis means to break down things in your body for like your metabolism. I was thinking of a different word though. Hydrolysis. No, maybe not for that. Lysosome in the cell. What's the lysosome in the cell do? Breaks down food. Lyse means to break. Good. Okay, going past this? Okay, thanks, Jalen. Anybody else? I see a couple people writing. Okay. So, this is that. I've covered it up. I'm skipping it. Okay, this is the next little blurb on your part. Physical and chemical properties. And a lot of these are just mainly, I want to explain to you a couple more examples, because you've already done the pre-work by looking at the reading guide. So if you didn't do the reading guide, then you probably are like, what the heck are we talking about right now? So, the physical properties are things you can observe without chemically doing anything to it, changing it whatsoever. So, you can melt something. Melting something is going from what phase to what phase? Solid to liquid. If you go from solid water, so H2O, solid, yeah, ice, to liquid, have we changed that chemical? We've changed the way it looks, right? So that's a physical change, because we never changed the chemical. We've changed the way it looks, so now it's going from solid and now it's a liquid. But we use this, we can see when it changes, and that will tell us the freezing point or the melting point of of H2O. Because you can go forward to melt it, but you can go in the reverse direction. You know, take liquid and freeze it, and that would be the freezing point. So there's different things we can tell about a substance without chemically changing it. So do you see what I mean by chemically changing it now? Okay, that's a physical change. We're going to get to that in just a second. So the characteristics that you should be aware of: boiling point, freezing point, melting point. Conductivity. Some things are naturally conductive. What's something that's conductive that's okay? Would you want to be in the ocean during a lightning storm? No. Some people are like, yeah, no, totally not. Because what's in the water? What's in the ocean? Yeah. What else? So what kind of salt? You say salt like, what is salt? There's sea salt. There's sodium ions. There's magnesium ions. There's calcium ions. There's all these things plus water. Okay? These things are conductive. It's going to shock you, okay? These things together with water are conductive. Pure water by itself, I can stand in a bathtub full of pure deionized water. What does deionized mean? No ions, right? There's no ions in it. I can stand in a bathtub full of DI water, drop my hairdryer in it, and I will be fine. I'm not going to try or demonstrate that for you. It's not the best, because my body will sweat and deliver ions to the water, but pure water, pure water will not shock you. Yeah.
What about like chlorine?
Chlorine is ions. It's hypochlorite. It's this and sodium and some other stuff. So no, don't get in the water. What else? Another question? Yeah.
So like the water, what about the water that's in the bathtub?
The water in the bathtub, if I filled it up with pure water, I would be fine. But our water is fluorinated and chlorinated, like tap water, because we all need fluorine for our teeth to keep cavities away, and chlorinated to keep disease and bugs out of it. So I would not do it in my tub at home because I have city water. I would have to have like my distiller pumping water in there. So those are properties that are physical. Oh, and we all know what malleability is. What does it mean? You can smash into a flat piece. I can't talk today. So sheet, thank you. Flatten it. You can kind of smash it and flatten it. Ductile means you can pull it into a wire. Do we know this? Do we not? Okay. Pull into a wire. Okay. That's what those two terms mean. Okay, so chemical properties are things that must be demonstrated by changing the chemical process or the chemical composition of it, right? So if I took, if I was trying to test out something's combustibility or flammability, what might I react it with? Well, fire comes from it, right? Oxygen. See, like this keeps coming up every time, right? So we can take some glucose and we can say, is it combustible? I don't know. Let's add it to oxygen, and we make carbon dioxide and water. So we have changed the composition of it. Some other properties are: is it reactive? Yes or no. That's a chemical property. Does it decompose? Is it acidic? And that's going to tell us more about its pH. Have we heard of pH? Yeah. Where's the acidic part of the pH scale? 0 or 14? 0, right? Because it goes A to B, acid to base. And then oxidizer, just something as a fancy term for reactive. Properties. Properties can cause physical and chemical changes too, right? So they relate to their physical and chemical changes. This delta symbol, we all know this means change. If not, we do now. Change means that's a shortened way of writing change. Physical changes, they will appear differently. So I'm gonna come back to that in a second. We've talked about like taking solid ice to liquid ice, right? I mean liquid water, liquid ice. That'd be awesome. Okay. Dissolving or sculpting. So what's an example that you can think of something dissolving in something else? Alka-Seltzer is actually a reaction. It's more than a tablet. Yeah. There you go. So Kool-Aid in water. Okay, and it's going to dissolve. And sculpting, things like Play-Doh, right? Are you really changing anything? No, you're just changing the way it looks. Making a mixture of food coloring, that's what I just did earlier. It looks like I'm dyeing the water. I'm not. What? It looks like I'm dyeing the water. Sorry. I was like, what did I say? Okay. So that's not a chemical change. All of these things are reversible. We can, take the Play-Doh, mash it back up. We can truly take the Kool-Aid out of the water. It's not easy. Like, we got time for that, nor the dye, but we could do it if we really wanted to. So those are the easy ones. The chemical changes are a little bit more interesting, a little cooler. So this one's going to actually form a new substance when it reacts, when the chemical change occurs. Sometimes you can't really see the new substance though because it's a gas, but you can detect it because you can kind of maybe it blows up a balloon. Maybe you see that it puts out a flame. What gas would put out a flame? Carbon dioxide. Yeah. Okay. Not oxygen. Right. Not oxygen. It would cause the flame to explode. Right. So this is a good example of a reaction that you're aware of because this is rust. So when iron is exposed to too much oxygen, it turns to iron 3 oxide, which is rust. We'll learn how to name stuff later. Gas evolution, I told you, is a fancy name for what? Bubbles, right? Okay, so if something forms bubbles, that's called gas evolution. That is an indication that gas is evolving and being created. Combustion means that you're reacting with oxygen. Usually with combustion comes what? Fire, flame, heat, explosions. No eyebrows, right? So, if you're too close. So we have a lot of other things that are indications of, or evidences of chemical changes with combustion. Precipitate. Who's heard of a precipitate? Okay, some of us have. Good. Now, you don't have to. I'm going to tell you right now. Precipitates are unexpected solids that come from two liquids. So if I take a liquid solution and I add it to another liquid solution, and then bada bing, bada boom, I get a solid. You didn't expect that, right? You expect it to be liquid. And that's because something new has formed. So, for example, if I took something called sodium chloride, salt, and added something called silver nitrate, another thing, it makes a solid. And you'll see it drop to the bottom of the test tube. I have an example I'll show you in a second. So that's called a precipitate. That's indicating something new is happening. Decomposition is another similar process. It's making gas usually. It usually makes a gas. when that's telling you that you've got something else being created. So anytime you make something new, it's probably a chemical change. Usually they are irreversible. Usually once you make that solid precipitate, there's no way you're going to pull it apart and put it back to its liquid form. And once you make gas, gas is hard to catch. You can't push it back the other way. So usually they are irreversible. Were you okay with this? Good? Yes.
What is RXN?
Reaction. RXN's reaction. Thank you. Yeah. I make up my own nice little abbreviations. I saw some of you guys using them on your reading guide, so I was excited. Picking it up. Another question? Yay? No? Okay, thank you. So these are a couple of them. You can see this is rust. Another, I write this down. When light is made, usually that's a chemical, evidence of a chemical change as well. So you can see this is glowing, illuminating. So light and heat are given off on these two examples. Those are chemicals. So you might want to add light evolution or heat evolution. I'll add it with you. Light and heat. Those are two more examples of physical changes. Chemical changes, not chemical. And then you've seen this happen before. We've seen neon lights. Okay, so that's a chemical change because we're taking the electricity and we're shooting it through the compounds and it's creating light. And then we've all seen water ice melt. So those are just some images to help you with some visualizations. So I think we went over mainly all of this. The only other things are foaming and fizzing is basically bubbles. So kind of that hits the gas evolution again. Any pictures we haven't talked about? Don't believe so. Oh, the new color. This is why I have this here. Okay. So if you put blue food coloring plus blue food coloring plus water, what do you expect to happen? Blue water, right? That is a chemical or physical change. It's physical. So a physical change is an expected color change. Like if you're putting something colored into something clear, it's going to change color. Like there's no question about it. That is very expected. So that is a physical change. But what if you put a clear liquid in a red liquid and it made a blue solid? One, it's making a solid, so you know it's a chemical change. Precipitate, right? Two, it's making a different color change that you never would have expected from these two. I mean, we know our color mixture kind of combinations. So this color change is a chemical change. So what I need you to know is that color changes happen all the time. Sometimes they're physical changes, sometimes they're chemical changes, depending on if they're expected or not. So we're going to see some color changes, and we're going to identify them later on our lab Monday, if they're chemical or physical. All right, I see some people need to write that down, so make sure you do that. We're almost done. So this is a slushy of sodium acetate. Somebody gave me this for Valentine's Day. One of my little nerdy students. It's sodium acetate, which is a compound. And if I break this little disc in here, it should solidify. It should be evolving heat. It's a hand warmer. So it is undergoing a chemical or physical change. Chemical or physical change because it's evolving heat. Chemical change, and it's precipitating out. Chemical change, right? So you guys can pass. It'll still be warm when it comes over here. So my fourth period won't get a chance to experience that my heart there because I chose you guys. I only had one. Okay. So now, keep passing, keep looking. Keep passing, keep looking up here. Now I'm going to give you guys a chance to do your couple of activities, okay? So I need to walk you through how to read the card sets that you're getting ready to use, and you can write this down or not, I don't care. And then I'm going to let you guys choose to do the card sets or get help with problem set 3B or do an extra credit assignment. But you are still responsible for doing at least most of this by test day. Test day, by the way, is next Friday, okay? Day before Labor Day. Okay, so next week we're going to do 2 labs, 3 labs, and a review day. So I didn't tell you guys this, every unit test I have a review day the day before. And what you do is the unit review on that day. So Thursday will be used as a unit review day. So you'll have time to ask questions and stuff before your test. Okay? Okay. Thanks, guys. Pay attention up here too as you go. Yeah. I'll tell you about that in just a minute. Okay, it's on the board over there too. Okay, so when you're looking at this, first of all, right here, do you recognize this as a mixture or pure substance? Mixture, because you see what? Two different colors. What do you think those two what is this green one right here? You see those two little, like, two circles smushed together, right? Is that an element or is that a compound? Compound, because compounds are combinations of two atoms, right? So this is an atom, which means compound. Okay, so that together makes a compound. The blue is the same. There are two little things together, and it's a compound. So this specifically is a mixture of a compound and a compound, which gives us a mixture. Is that mixture, does it look, if you look at it, you see big pieces and small pieces, right? I would call that heterogeneous. It's sometimes hard to tell on these pictures if it's hetero or homo, but you can kind of make your best guess. Okay, so looking at this one, same story, compound, compound. Do you think this is a solid, or a liquid, or a gas? Okay, so it could be solid because it's kind of close. It could be liquid because it's kind of close. This one is definitely a what? Gas, because it's separated apart. So you can kind of see some of the regularities in how the pictures are described here. Okay, this black and yellow one. Tell me what you know. Mixture or pure substance? Mixture of what? Two what? Elements, right. We have two elements here, and they're elements because this black thing is one atom, and this yellow thing is one atom. They're not combined with another black or yellow thing, okay? You kind of seeing what we're doing here? Okay, let's look at two more. This one up here, this one. Pure substance of what? Okay, of compounds which are in their gaseous state. Yeah? Fancy. Compound in gaseous state. Good. This is a compound and it's liquid, and this one's solid. Solids are usually very organized. Liquids are kind of and gases are kind of Okay? So you can kind of see what we're doing here. One more for the road here. This one right here. Mixture or pure substance? Mixture of. Don't tell me the states yet. Mixture of compound and atoms, right? So this right here, this little guy with the four legs, is a compound because it's a combination of atoms, and this is just one old atom. Okay, so that's an element because atoms are elements. Okay, so that's a mixture, and that's homo or hetero? Hetero, because it looks different everywhere. Okay, the one up here was also hetero. This one is homo. All right, so I have little sheets on the back table, and you can work with a partner on this. It's yellow, okay, look back here, eyes. So basically, what you're going to do, you have a card set, and you are going to label A through infinity. There's a bunch of them here. It says A through R on some of the papers, and some of them say A through infinity, because I don't know the end numbers on this right now. So you're just going to classify them as pure or mixtures, and then identify the pures. It's just like letters A through infinity for mixtures and pure substances, and then a little bit more with the mixtures. So this is really easy, but it's easy practice. You can do that right now if you are pretty good at concept 3B, and keep that on your desk, okay? After you get done with that, you can start your homework, which is an online assignment on chemical and physical changes. It's an online link, so under Tax Homework, you pull it up, and it's a Google form, and you just fill it out, and then submit, okay? If you need help with concept 3D, I'm going to be at the board. I need you with me, so you're going to move closer, okay? Everybody there's got concept 3D on their desk. So if you're going to the back, go to the back. If you're staying in front, stay in front. Yeah. Yeah, let's get help go. It's too warm. Choose a partner. No, you look at that. Okay.
Oh, yeah. One bathroom break every 2 weeks, right?
You can go. That's fine. Sign out on the door, okay? If you need help with problem set 3B, you need to come this way for me. If you're going to the back, go to the back. I'll explain it to you.
So what?
Do we write on a separate sheet of paper?
Anything colorful? Okay. Problem set 3B? Okay. Threes, 3B,
Yeah,
3B.
I just have like one question.
Okay, you just have one question?
Yeah, like about one of the problems.
Oh, let me pull it up now. And let me stop videoing, because I'm still videoing.